All right, here's practice problem number 3. Now this one's going to look a little bit different than the last two, but the point is we're still going to set them up the same way and then eventually get to the type of equation we want to use for these problems. So the biggest thing is being able to read through, figure out what we know and what we don't know. And hopefully the what we don't know is only one variable, and then we know what equation to use. So as I read it, you have a tank that holds 5 liters of a gas for the welder, right? How many moles of gas, O2, would be in the tank if it is at STP? All right, so as we go through that problem, we write down our knowns and unknowns. The first thing we run into is a volume, right? So we have 5.00 liters, okay? And it asks for how many moles. So we write N is equal to that. So this is definitely what's different from our first two problems. Our first two problems held moles constant. We didn't even hear about them. But now the number of molecules, right, is coming into play. We've only had one main equation that deals with that, and we'll be able to see that in a second, of O2, right? So we could put of O2 right there. That might be handy. If the tank is at STP. So remember, STP stands for standard temperature and pressure, right? So standard temperature is 0 degrees Celsius, but we can't have that. We have to add 273 to it to get to Kelvin. So we're actually at 273 Kelvin. Okay. And pressure, you can choose any of the pressure units. I guess probably the easiest one is just 1 ATM. All right. But you could have used 760 torr or 101.3 kilopascals. Wouldn't have mattered. It would matter when you came to do the next part. And the next part that's not on here, that's not given to equation, is our R value, right? And our R value in this case is going to be dictated by the pressure unit. Okay, so you'd have to look for the one that has ATMs in the R value, and that would be 0.082, and that is liters, ATMs, over moles K, right? So that's a big unit. We'll see that that works out, right? So basically, anytime we have N involved, right, we know we're going to be using the ideal gas law, Pivner. So if I have PV equals nRT, right, there's no ones and twos because there's just one of every one. I got to solve for N. So my N is equal to PV over RT. All right. And if you do that first, then it's just a plug and chug. So my P is 1 ATM. My V is 5.00 liters, not 500. My R is 0.082 liters, ATMs over moles K, and that is times my temperature of 273 Kelvin. All right, so now when we go and we take a look at this, algebraically, everything cancels that it needs to cancel. ATMs, ATMs, liters, liters. All right, that's on the top, this is on the bottom. That's good. And really this moles is divided and divided, so that's actually going to come to the top, right? It'd be like we're multiplying it. So that's good, right? That means we're solving for moles, which is exactly what we wanted. So we just put that into our calculator, and we can find out that we have 5 divided by 0.082 divided by 273. And so we end up with 0.223, right? Using our 3 sig figs from right up there, moles O2. Okay, so that's what this question gets us. What if it said instead of moles, what if it asked for grams? Okay, we would do the exact same thing, and maybe that makes a little bit more sense because grams is a little bit more useful to us, right? But all we do is we take this number, right? We take our 0.0223 moles of O2, right? And we would go back and we use our molar mass. So 1 mole of O2. Now this is the key. It's O2, not just O. So grams of O2 is 16 times 2. So we'd have 32.0, right? Moles cancel. So we have 32 times 0.223. And we come up with 7.14 grams of O2. So this is the original answer, but we can use that original answer once we get to that moles level to kind of go anywhere we need to. All right, so there is a look at how to do a ideal gas law problem.